All right, in these notes, we are going to start an introduction on 6.1, which is the start of our exponential unit. So there's two new words that we're going to follow: radical and exponential. So these are just two ways or two forms of writing a number. Now, if we start with, let's just say 6 raised to the 2 over 3, this is called exponential because you see the exponent. It's actually a rational exponent because the exponent is a fraction. It's a ratio. Now, if you look here, if we want it to go backwards and make radical form, we're going to draw the radical. And the most common radical is square root. However, this one is going to be a cubed root. The bottom number of the exponent goes on the outside. The base stays the same, and then the 2 gets dropped down. So all you're doing is rewriting the form. It started exponential and then turned into radical. Now for this slide, and I'm not going to go through all of the slides, but we're starting out with the exponential form, and then it says the use of radicals. So you want to draw your radical with the base. The 2 goes on the outside, and then the 3 gets dropped down. Now, if you are following along, the easiest thing to do is open this keypad, and you want to click this one that has the N. So then you're going to put the 2, it needs to be up in the air like that, 5, and then the shift key, 6, and then 3. All you're doing is rewriting it. We'll do this one real quick. 5 raised to the 4 over 3. The 3 gets kicked out. The 5 still is the base, and the 4 gets dropped down. Make sure you click the correct one. We need the one with the N because that number matters. And then it's going to be 5 to the 4th underneath. Now I'm going to skip slide 6 so we can make this a shorter video than needs to be. Actually, 6 is going to be helpful, so I'm not going to skip it. This is the other way around when we have... Actually, no, I've already done this one. So if you just do the square root and then 7 raised to the 3rd power. So I'll let you type that in the keyboard. Slide 7 is the same way. Slide 8, we're now going to start with the radical. And we're going to work our way backwards with writing the base. The 7 moves up top, and then the 4 goes underneath. So for example, we have the 5th root of 3 raised to the 4th power. We have a base of 3, and then raise 4 to the 5th power. Now how you type that, you just type in 3 caret key, which is shift 6, 4 divide by 5. The divide key is the same as the question mark. Same idea here. This is the cubed root of 5 to the 8th power. Keep the 5, move the 8 up, and keep the 3 on the bottom. So I'm going to skip these because they're the same idea. Now, on slide 13 is when we really get into the algebra part. So we have these equations, but now the variable is in the exponent. So the first thing you need to ask yourself, is the base the same? It is. It's a 2. Since it's a 2 on both sides, we are allowed to drop down the exponents and make an equation. So this is going to be a 2-step, just like we always have. We're going to add 3x on both sides. We got 6x equals 0. Divide by 6, x is going to be 0. What that means, and this part you don't have to show work on, if you plug this back in, you are going to get the same answer on the left as on the right. So this is going to be 2 to the 0 equals 2 to the 0, which is what we want. So that's how you know that you did it correctly. Slide 14, same thing. We have the same base. Since we have the same base, we can bring down the exponent. I recommend drawing your wall so it keeps it straight. 2x equals 3x plus 2. And then we can minus 3x on both sides. And then x equals negative 2. So once again, if I plug that negative 2 back into the equation, I'm going to get a true statement. So I'm going to get 6 raised to the negative 4, and then I'm going to get 6 raised to the negative 4. So I know that I did this correct, and x really does equal negative 2. You can try slide 15 on your own. Slide 16, in middle school we had a review. We had exponents. And in exponents, we should have learned, and if you didn't, that's okay, that when you multiply the same base, you can add the exponents. So in expanded form, you may have learned 3 squared really means 3 times 3. Well, what happens to this 3 to the 4th? That means 3 times 3 times 3 times 3. And in the middle school, you may have had to count all of these. 1, 2, 3, 4, 5, 6. And that's where the 6 comes from. That is a long process. So if you just remember that you add the exponents whenever you multiply the same base, you'll be fine. So let's get on to those problems. We have 4 raised to x over 2 times 4 raised to x over 5 equals 4 to the 7th. Okay, what we do, we notice that all the bases are the same, so we can move on. We can proceed. We also are looking at this multiplying. Multiply the bottom means we add the top. That's what slide 16 said. So we have the x over 2 plus, because we're adding, x over 5, and then the 7. Now the only tricky part of this is the LCM. You have to do LCM 2 comma 5, which is 10. So 10 times 1 over 1x over 2 gets you 5x. This would get you 2x. And then 10 times 7 would get you 70. So then that's 7x equals 70. And then x equals 10. All right, so same rule applies here. This one's actually even easier because we don't have any fractions. So our bases are the same, so we can move on. Notice that I'm multiplying here. So I'm going to have to add up here in the sky. So 2x plus 4x equals 12. Now this is just going to be a two-step equation. We're going to do 6x equals 12. And then we're going to have x equals 2. Now that's not the only property that we're going to use. If you go to slide 19, we have the quotient rule. Quotient rule means whenever you're dividing the same base, it really means you are minusing. So take the top exponent, write it first, and then it's 5 to the 1, which your middle school teacher may have had you write expanded form. So 5 to the 4th means 5 repeated 4 times. And then you're allowed to cross out the same thing on numerator and denominator. And what do we have left? We have 5. So this is just an easier way to remember that when you have the same base and you're dividing, you subtract the exponents. So for here, we have 3 raised to the 2x over 3 raised to the 4 equals 3 to the 6. Okay, remember, we are dividing, since that means we have to minus. Now do the 2x minus the 4, and then don't forget the equal 6. So when we divide same bases, we minus the exponents. So then we have 2x equals 10. And now it's just a one step, which is x equals 5. Same thing here, same base being divided, so we have to minus the exponents. 3x minus 1 was all on top. This was our top exponent. Since it was our top exponent, that's what comes first. Now minus, because we're dividing, 5x, and then drop down the 9. We're going to combine like terms. We're going to have negative 2x minus 1 equals 9. Now, once we do that, we're going to add 1 on both sides. We have x equals negative 5 and x equals negative 5. Now, if we don't have the same base, we can make it the same. For example, if we have 9 and we want a base of 3, 3 squared gives us 9. If we have 125 and we want a base of 5, we can do 5 to the 3rd, because 5 times 5 times 5 gets us 125. Now that's going to make more sense on our next slide. So notice here we do not have the same base. We have the base of 5. So we have to make 125 the base of 5. Now on the calculator, 5 to the 1st gets you 5. 5 squared gets you 25. 5 to the 3rd gets you 125. This is the one that we're looking for. So we're allowed to change it. We're allowed to do to the 3rd power. So then we have this two-step equation, just like we're used to. Now I'm going to let you try slide 24 on your own. It's the same idea. And it's okay on this side part right here that you're showing work or doing it on the calculator. I'm not expecting you to memorize 5 to the third is 125. I do expect you to look in the calculator though. All right, the last problem we're going to go over for this, we have 64 and then x plus 1 in the exponent, 4 raised to the x plus 7. We need 4 over here. So 4 raised to the 4 is too much. 4 raised to the third is 64. So I can do 4 to the third. And then notice that I already have an exponent. So I need to put that in parentheses. So this is going to be my new problem. I now have the same base. So now I can solve it. Remember, we need to distribute. I'm going to show my work over here. So 3x plus 3 equals x plus 7 minus x on both sides. 3x minus x gets us 2x. And now all we have is a two-step. So 2x equals 4. And we're going to divide by 2. X equals 2.